Everyone. So today, as George has mentioned, we're going to look at Nextflow and NFCO. It's one of the workflow management systems that we use mostly in bioinformatics or any other analytical method that we use. So as you see there, my name is Juma. I'm a graduate fellow at ILRI and a PhD student at University of Western Cape, Sunby. So by the end of this brief presentation, we should be able to answer a couple of questions highlighted there. And the objectives are also indicated there to have an understanding of what a workflow management is, understand the benefits of using a workflow management system, explain the benefits of using Nextflow, and explain the components of a Nextflow script, and importantly, run a Nextflow script. Yeah, so when you guys analyze your data, normally you undertake a series or a sequence of steps. This can be tasks, including gathering, cleaning, and also processing the data. Now, these tasks are often called a workflow or a pipeline. Traditionally, guys used things like Bash, or you could write a script in Python to try to stitch the steps into a single workflow. Here we see an example of a workflow or a pipeline which does variant calling for both germline and somatic variants. So the different steps from processing to variant calling to annotation and finally reporting would comprise what we call as tasks, and the entire aggregation of those tasks is what is called a workflow or a pipeline. So a brief overview of the workflow management systems. So as it has been mentioned previously, we have workflow management systems such as Snakemake, Galaxy, and Nextflow, which have been used for mostly computational data analysis in bioinformatics, imaging, physics, and chemistry. Now, an important feature of these workflow management systems are highlighted here. One is the runtime management, and this generally encompasses the parallelization or splitting the tasks and data to run at the same time. These workflow management systems also have a feature on software management, which we discussed extensively, I think, Monday, Tuesday, such as Docker and Singularity, but also Conda to manage the dependencies within your environment. These management systems also have portability and interoperability. So you can write a workflow in one system and be able to run it in a different computing infrastructure. For instance, you can run it on a local computer and further take it up to the cloud. And so that is what we're referring to portability. You can move it from one system to the other. They also are reproducible, meaning that if you run the pipeline with a given output, you get the same results. And they also feature what they call re-entrancy. So this is like allowing you to resume, in case you are running your workflow or your pipeline, if it stops or if it breaks down, you are able to resume that run. So that is what we call re-entrancy. Now, here I highlight differences between Nextflow and Snakemake. So Snakemake as a workflow management system is built on Python. So most of the syntax that you have seen in Snakemake are built based on Python programming. On the other hand, Nextflow is built on Groovy, which is technically Java programming language. Also, in terms of the data, Snakemake expects that everything you give it as input and output is a file. But in Nextflow, you're using both files and values. In terms of execution, Snakemake will always work within the working directory in which you're running it. In Nextflow, each job or task has its own directory. The philosophy behind Snakemake is that it's pooled, so you explicitly have to state both the inputs and the outputs. However, in Nextflow, it's a push whereby you don't have to give the file their names. So you just give, you just need to mention that I expect this input. So at the end, the steps are stitched in such a way that you are able to get still the outcome without having to explicitly put the output files expected for each task. Another difference is that in Snakemake, you can do dry runs, as you had seen, using the -np parameter. But in Nextflow, this has not been implemented, although I think they're currently working on something called stubs, which enables you to run, to do a dry run. In terms of tracking code changes, Snakemake does not allow for tracking of the changes, while Nextflow does that. So what?
How do you mean by that last statement, tracking changes? Like, what that look like?
So tracking changes, for instance, you've written a process, or in your task, within your script, you have amended something. Maybe you've added a flag or a parameter. Maybe you are running some tool sort, and then you want it sorted by coordinates. If you had not indicated that, then it's able to see whatever had happened previously and append whatever flag or parameter that you have put. So you are able to see the difference both in the outputs. I don't know whether that's clear. Yeah. So in terms of the scripting language, as I said, Nextflow is written in Groovy, which is a superset of Java. However, it is a domain-specific language, meaning that it is a language which is intended to simplify the writing of workflows. For instance, if you're writing an SQL script, if you're working on databases, you will tend to use SQL scripts. If you're working on text processing, you will work with awk. So DSL is a domain-specific language which Nextflow uses in order to simplify the writing of your workflows. And as it is alluded there, it is typically or technically a Java programming language. So here we see that the approach of having a simple DSL built on top of a powerful general purpose language, which is Java, allows or makes Nextflow to be very flexible. It is able to handle most use cases with ease, and also it can be able to handle corner cases which may be difficult to implement using native DSL. So there has been changes with regard to this domain-specific language with regard to Nextflow. From version 20.07.1, there was a revised syntax in the original DSL, and this is known as DSL2. So the advantage of this DSL2 is that it has allowed workflow developers to use what they call modules. So it has an improved modularity, and this allows the pipeline developers to reuse code or modules. It also has improved the data flow manipulation in that in the syntax, when you're manipulating your data flow or your data input, you can be able to do that with ease. And this feature can be declared on top of your script using that directive, nextflow.enable.dsl2. So we can look here keenly on what a Nextflow script would technically comprise of. So the workflows have three main parts. We have processes, we have channels, and the workflows themselves. So processes will describe a task. similar to what you saw in Snakemake, using the rule keyword. So, for instance, you were running BWA map, and you were using the keyword rule. So the counterpart of that in Nextflow would be a process. So it's just describing a task that is supposed to be run. And this process, you can use any script to describe whatever you want to run. You can use Bash, you can use Perl, Ruby, Python, R, whatever scripting language you're comfortable with. And these processes are executed independently, and they're not able to interact with other tasks. One of the major components of these processes is that the tasks, the data in each task are passed as asynchronous queues or channels. So they're not in synchrony. So if you give, for instance, in your process, you are doing BWA alignment, the input that you pass on to the next process does not depend on the order in which you give the file. So it's fast in, fast out kind of queue. The channels here refers to the data flow, or what you guys were calling as. So in Snakemake, there's no channels. I think you just specify the input. But in Nextflow, we use channels to manipulate the flow of data from one process to another. So, for instance, if you're doing BWA mapping, you specify your input, but that input, when you want to give it to the next task, you have to use some kind of a syntax which they call a channel. So here is an example of a channel containing 3 components. As you can see here, we have this channel. Technically, these are data. So you have your reads, first queue A1, 2, 3. And this is the process. You're running quality assessment on your files. So you give it the process which is going to do that. And then this will output whatever output FASTQ gives, but now you have to say that the output is a channel, which now is passed on to the next process. So it's just like an input from one process modified to a channel, and then that channel becomes an input to the next process, and so on and so forth. In terms of execution, you can be able to execute the script on your local machine or on a high performance computing cluster or even the cloud. So if you don't specify, the executor will automatically run it locally on your computer. So here's an example of a process block as used in Nextflow. As we had said, to enable DSL2 syntax, you give it this directive, and then the process begins. So it's a block, as you can see. This is typical of Java. So you begin with a keyword process and then the name of that process. So if you're doing fastqc, you just do process fastqc. Normally they like the convention to be in uppercase, so you can name your processes in uppercase. Followed by that, you have the directives here, and so this could be one or many. Example, you could give it a tag just to identify what it is doing. You can give it a label. So the label there could correspond to the amount of memory it requires or the amount of CPUs it requires. But you also have a similar kind of syntax with Snakemake, in that you give here the inputs, and these could be qualifiers. We will see later on. You give it outputs as well, and you can also have conditionals within the code block. And then finally, you have to give it a script or a shell or an executable. So here's an example of a process which is going to, we are naming it process BAM. So typically it's going to process a BAM file. The script is indicated here. You're first sorting, then after sorting, you are indexing and generating some statistics on the sorted BAM file. So as you can see here, it is not necessary that you have your inputs or outputs. They are optional. You can also run a script. As I told you, Nextflow supports running any scripting language. This is a Python script, which I think basically counts the number of reads and bases in your file. And down here, you can execute this as a workflow by calling this process. So there is a keyword workflow, which enables you to put all your processes within that workflow so that they're run in one. Yeah, so here I wanted to highlight a script that I think we will access later on. I think it's better if I have it shown, but my laptop is not connected at the moment. Or can we look at it later on? I can progress, but we can look at it later on. So in summary, I mean, Nextflow is a workflow management system that allows you to write codes using different scripting languages. It's able to also orchestrate tasks using data flow programming, as we have seen using channels. You are able to do software management using Conda, Docker, and Singularity. It has a built-in version control with Git. And you can also execute these workflows in different platforms such as Slurm, Cloud, yeah, and all that. So briefly, I want to touch on channels and operators. So channels are asynchronous, which means that the output from a set of processes will not necessarily be produced in the same order as the corresponding inputs went in. So you can have FASTQ file 1, 2, 3. So the order in which the channels are emitted are different from how you give it in. So it could when emitting, it could start with FASTQ3 or FASTQ2. It's dependent on whichever file comes in first. So it's a queue which is dependent on first in, first out. So the first file that is read will be the same file that is emitted. So it's not in synchrony. We have two channel types in Nextflow. We have a queue channel, and here is a channel which consumes sub data. And this is typically an output from a process, or it can be a channel created using what we call channel factory methods. So in Nextflow, we have methods which allow us to create channels. It could be a channel of, a channel from path, a channel from SRA if you are getting data from the sequence read archives. We also have value channels. These emit single values or singletons, and the advantage of this is that it allows you to reuse that channel throughout your workflow or your pipeline. It's important to note here that in DSL1, the previous version of Nextflow syntax would not allow us to use a channel more than once. However, with DSL2, you can be able to reuse that channel because it has improved modularity. So as I mentioned, the queue channel, you can have channel of, channel from list, channel from path, from file pairs, and from SRAs. Here are examples. So here you have a channel For instance, in a directory, you have a file or a folder having this name, and you want to create a channel from that. So you just do a simple syntax like this: channel value. They are in round, how do you call them? Round brackets. So this will qualify to be a single value channel. When you look at the second one, it's still a single value channel, but it takes in a list of files or a list of files. So you have one file which contains chromosome 1, 2, 3, and 4. You can still make channels using channel of, as you can see there. There's also manipulation of the channels. So there are methods, for instance, mix. You have two channels. You have created the first channel, which is a channel of these numbers. And then you have the second channel, which is a channel of a string. When you do channel 1 dot mix channel 2, it creates this kind of a channel. So you're able to manipulate your channels at the same time, and this is the advantage of DSL2. And then you can gather the channels using channel.collect, which allows you to have a list of all your values. So channel from path, this is a channel which enables you to have, for instance, in your directory or in your folder, you could have several folders, and you're only interested in getting the reads or the sequences emanating from a sequencing experiment. So you have to specify the path to where your reads are, and then from there, the Nextflow will be able to gather all these sequences or these reads that are in that folder. So Nextflow also allows you to use some sort of wildcards, as we had seen in Snakemake. So here we have, you're getting both forward and reverse reads from that path. And looking at the patterns of your file, you can give it a syntax like this. So you give the path, the relative path of where your reads are located, and then you use an asterisk, and then using this pattern, you can be able to grab all the files that have those patterns. When looking at channel from file pairs, so this is what will qualify to be a tuple. So it generates a tuple with the sample ID and a list of the files. So in here, we see the difference when you use from file pairs, you get your sample ID as well as the corresponding files. So get the difference. I think this would be ideal if you have many files and I saw some of you are struggling to get the sample names when using Snakemake. You can also do some transformation on your channels by using transformation methods such as filtering. So if you have a channel which has both numbers and strings and you only want to emit numbers, you can do channel.filter into brackets number, and it will give you an output. You can also use other transformation methods such as map. So map will create a kind of a key value relationship like what is called a dictionary. But here what essentially this transformation is doing is that we have this channel containing these values, and we want to replace all the instances of CH, I think there was a typo there, because this one does not have R, but essentially it's replacing all the instances of CHR with a blank or an empty kind of thing. So the it here is an item. So each item within that channel is going to have this replacement. You can still perform some things, transformation like flatten, where you have a list of values and you want to emit single values. You use a flatten method. You can collect values from a channel and have it in form of a list using the dot collect. You can count the values in a channel by using a method called count. So the other thing I wanted to mention was on Nextflow Tower, which is an open source monitoring and management platform for Nextflow workflows. It was developed by Sekera Labs. You can install it on your local computer to monitor your pipelines, but you can also install it within an organization that is the enterprise version of it. So some of the things Nextflow Tower will give you is that, I mean, if you're in an organization and you have a couple of pipelines that you're running, you're going to, it promises improved productivity, it removes complexity, it reduces costs, and also simplify compliance. It has a very